So, Jiva, occasionally there are errors. Now, we're not talking...
I don't write any code with errors.
Yeah, but we're not talking compiler errors here, are we? We're talking errors occur while our program's running. And we need to have effective error management.
Indeed we do.
What does Objective-C offer us?
Well, I'm glad you asked.
That's convenient, really, isn't it? Otherwise, you'd have been a bit stumped.
I would be. There's actually several different error management mechanisms that Objective-C provides to you. I kind of like to boil them down into three major categories. Basically, it comes down to return codes. So you can have your methods return, yes or no if something succeeded, or some kind of special code that indicates success or failure. Exceptions, which are there really for exceptional circumstances. And then finally, there's a new mechanism in Objective-C called NSError, which kind of is almost like a nice sort of middle ground between return codes, which are very simplistic, and exceptions, which are on sort of the extreme end of, if you don't handle the exception, your application's going to die kind of situation. Right? So I guess let's take a look at, all three of those. So in the example code that I've got here, in all three of these cases, when we're talking about this, I'm going to, imagine that we're making like this network client, something that's going to connect to a server, and it might have various error conditions that can occur as a result of that. For example, the server might be down, the network might be down, those kinds of things. So probably the simplest kind of error handling that you can have is just whether or not it returns successfully. So for example, here's a very simple connect to server method. Let's just imagine that we've got this connect to server and we're taking in this server name. And we open a socket and we save the socket. We've got that's a member variable that's sitting out there. And basically we just check to see if the socket is valid or not. Is it not a zero, in other words? And if it's invalid, then we're going to return no. If it is valid, then we just return yes.
Don't you need to change your return type?
I do. I'm sorry. You're right. Good
That's
call.
All right. Just shows up in listening.
I guess that proves that I do write code with errors.
I don't like to feel smug or anything, but there we are.
All right, you got me. Anyway,
and we're not going to cut that bit either. We're carrying on.
I'll bet you won't. Anyway, so we have so in this case, we're basically returning an error code. Either it's a yes or a no, depending on whether it succeeded or not. Now you could return an int, for example. In fact, commonly this is often used in like C applications in particular. You might have a return code that returns, a positive integer if it's successful, or even a zero if it's successful, and then maybe some kind of anything other than a zero might be unsuccessful, or and then the number that's returned might be something that you go look up in an error table somewhere or something along those lines. To give you an idea of how you might check these errors, right? Here's a main where we're actually pulling up the network client. We've created it, and then we go to connect to the server, and we just check, if connect to server returns successfully, in other words, it returns a yes, then we can go ahead and do stuff with the server. Otherwise, we go tell the user the server is down. Now, the big problem with return codes is they're kind of dumb. I mean, and I don't mean like they're dumb as in they're stupid, but I mean dumb as in you don't get a lot of information out of them. You can, sure, you can have it return some kind of a number, and then you can have it go look up that number in a table and things like that. But, the big problem with that is, especially for users of your API, they're getting back this number, and unless they know about your table, unless they know how to go look that number up, it gets really kind of hairy. I personally have worked with APIs that just use return codes, and I get back this return code that was like, 50,321, and I'm like, what in the heck does this mean? It was completely useless to me because it was just a number, and I didn't know where to go look up that number to see what the error code actually meant. So to me, working with return codes, yeah, you can use numbers. Okay, that's one way you could do it. I suppose you could also have it like return a string. That's another way to have it handle errors. But really, to me, I think return codes are really only suitable for very simplistic problems in runtime problems. Things where you can just return a yes or a no, whether it succeeded or not, and how to handle that from there. Okay. The next type of error handling is sort of on the opposite spectrum of that, and that's exceptions. So exceptions are there for truly exceptional conditions. A lot of languages, if you're coming to Objective-C from things like Java or even Python, those languages tend to use exceptions a lot more liberally than Objective-C does. Probably, I think it's safe to say that they almost, in some ways, actually use exceptions sort of for program flow control in some ways. They don't necessarily use exceptions for truly exceptional conditions. In Objective-C, exceptions are really meant for truly exceptional states, things that your application just cannot recover from. The reason for that is because if a caller to your API doesn't catch the exception, then your application is going to crash. And that's a really bad user experience. It's going to crash because an unhandled exception is considered a fault condition. So, important point there, make sure you're only using exceptions for really exceptional conditions. So, to give you an idea of how to generate code, how to use exceptions for handling, again, we've got, our connect to server method, and we check to see if the socket is good or not. And if it is an invalid socket, then maybe we do a little bit more investigation and we say, is the server reachable by using this server is reachable method? If the server is not reachable, then we go ahead and we construct one of these exception objects. This is a special object in Objective-C. It's a class just like any other class, and you just make one of these guys, and you can pass it a name and you can pass it a reason. In this particular case, we're saying error connecting is the name of the error, of the exception, and the reason is that the server is down.
Right.
Now, we also have this user info dictionary where we can pass information up the chain if we wanted to. In this particular case, it's being set to nil. But maybe we might want to put in the socket in there or something along those lines. It's a dictionary that you can use for that purpose, right? Once you've created one of these exceptions, then you use the special @throw Objective-C statement, which actually takes that exception and throws it up the chain there. And actually, this actually needs to go in here because it would have been out of scope. So, in this case, so then you throw that exception and it goes up to the caller. Now the caller has to catch that exception, and I'll show you how you do that in a minute, because if you don't catch the exception, then like I said, your application will crash. So, and then the cool thing about exceptions is that you can create other exceptions. You can throw exceptions with special descriptions for different error conditions. So in other words, let's say that we determine instead the server is the network is down. Here's another case where we're checking to see if the network is up, and then we create this other exception, and instead we say, hey, the network is down. We can't connect to it. Now, actually, the truth is, this error probably should go above the other error, because if the network's down, then certainly you're not going to be able to determine if the server is up. But
we're trying to probe principles here.
Let's not be pedantic here. The point is, you can look for different kinds of error conditions and then throw different exception error messages. That's kind of the key. And then finally, if you can't figure out what's wrong, if all else fails, you could still just throw an unknown exception. So let's go take a quick look at how we actually catch these exceptions. So here's our main, again, rewritten to handle these errors with exceptions. There's a couple of Objective-C constructs that are built right into the language, just like that @throw statement was built in there. There's the @try statement. And what this does is you basically say, I'm going to try to do everything in the following block of code. if any of it throws an exception, then come down and try to catch my exception. So in other words, we start off, we do this @try. Now, everything in this code block, it's going to happily go along, executing each one of these. And if we throw an exception here, it's going to stop what it's doing, and it's going to jump down here to the exception handler, to this @catch handler. And it's going to execute this. And when you construct the @catch handler, you pass in a variable to catch the exception. So here we're saying @catch and this exception E. So I'm grabbing this exception, and then you can do stuff with that. So for example, I can say, what was the name of that exception? So if we go back to that other code where we were just looking at the exception code, right? Where we were saying exception with name, that name is going to come over here and be available to us right here. So we're going to get that name up here. Same thing with this reason, right? I'm going to get the reason. And then, awesome, I can actually tell the user exactly what the error condition was. I have control in the caller of how to handle that particular error, which is great. That's one of the real huge powers of exception handling. Now, if the exception doesn't occur, right? If we get to here and no exception occurs, then execution just keeps happily going right along. You go ahead and you just keep executing, and there's no problems at all. Now, another cool thing is that if there is other code in here that also throws an exception, then you can also handle those exceptions here too. So if you had a different call that also threw an exception, then you can catch those exceptions here as well. And I'll show you how to do that in just a second when I show you how to catch particular exceptions. Now, so you've got the @try statement, right? That sets up this block where you're going to try to do this stuff. Then if any of that stuff fails, then you catch the exception and you go ahead and handle that with your error handling. But, one of the interesting things is, of course, because you threw an exception, things have been interrupted, right? And so sometimes you need to make sure that you do some cleanup. For example, in this particular case, right, we've allocated an NS auto release pool, and we want to make sure that we release that NS auto release pool, right? Or that we drain it. Or for example, we allocated this client here, and we want to make sure that we release that client. So that's why Objective-C provides us with the @finally keyword, which basically allows us to define another code block that no matter what happens, whether an exception is thrown, whether the code is successful or not, the @finally block will always be executed. So we don't have to duplicate our cleanup code both in the try block and in the catch. We can just put it all into the finally block, and it will always be executed regardless of whether an exception is thrown or not. And again, we get to leverage that kind of cool Objective-C feature where objects that are nil, when you send them a message, nothing happens, right? If, for example, an exception occurred before we actually initialize something, it's perfectly safe to still call release on it because it's probably set to nil, it is set to nil, and so you don't have to worry about it. It's all good, right?
Now, I just look at this, and I know that for Java programmers, as you've said, for .NET programmers, if they've come from the Windows platform, for Delphi programmers, that looks like actually what they would consider standard error handling code, because exceptions are just considered the way you do errors on those platforms.
Right.
And it looks similar, and I'm guessing it's like there's an exception will bubble back up the call stack until it finds itself in a try-catch block, and then we'll do that. But you're saying within Objective-C, this is not encouraged to be your standard way of doing errors. This is for extreme things that should cause the program to not necessarily fail because we want to capture them, but it's for something like there is no network and you've got a network monitoring program.
Exactly.
It's something that's not going to be a normal expected result. So you wouldn't expect necessarily to throw an exception if you were looking for a record in a database and it wasn't there.
Precisely, yeah. It's definitely for exceptional conditions. That's the whole point. If you're dealing with something that is easy to recover from, probably an exception is not the right place to go. Probably you want to be looking more at NS error, which is what we're going to look at in just a minute. Before we do that, though, I wanted to make sure that we also cover how to throw and catch particular kinds of exceptions. So let's take a quick look at that. So again, if we come in here, I have another version of this function where instead of just calling or just creating a generic NS exception and just throwing that up the stack, instead we're actually creating custom subclasses of NS exception. In this case, like for example, it's a connection exception. And we're throwing those up the stack instead. Now, of course, we can still fall back to the standard old NS exception down here if we can't figure out what this is. But otherwise, we can say, connection exception for in the case of I can't connect to the server, or you can say network exception in the case where, the network is down. And you create a specific subclass of NS exception and throw that up the chain. What that enables you to do then on the calling side is you can actually say here you can catch specific types of exceptions. So here I'm actually saying I want to catch connection exceptions. If I want to handle that kind of error differently than say how I handle network exceptions, then this is how you would do this. In the same way, if you had other code in here that does other things that might throw other kinds of exceptions, you could handle those exceptions in other catch blocks without having to revert to, like, for example, looking at the name of the exception or something and doing some kind of an if else or something along those lines based off of that.
I'm guessing these custom exceptions are just descendant classes. They just inherit from NS exception.
Yes, that's exactly right.
So if we wanted to, we could add our own properties and our own data and everything that will travel with the exception.
Absolutely.
So if like in the network error one, if there were certain things that you're always going to know about a network error, you could just set all those properties on that exception, and your error handling code could pick that up.
Definitely. Although, of course, you still have that user info dictionary. So, that's another place that you could store that information as well. But yeah, definitely you could make your own and maybe expose, maybe you could even write some kind of an accessor where you actually set the information in the user info dictionary and then just write a convenience accessor that goes and pulls something out of the user info dictionary. There's several of those kinds of methods already provided for you on the NS exception class itself, like the name property and stuff like that.
Okay.
So that's the gist of handling exceptions on Objective-C. So let's take a look at the third mechanism for handling errors in Objective-C, and that is using a new class called NSError. Now, NSError sort of combines the best of both worlds, in my opinion. I really love NSError because it's like the perfect spot between return codes and exceptions. It gives you the ability to return very descriptive errors that tell you exactly what's happened. You can set an error code in them. You can set a description. There's all kinds of cool stuff that you can set in them. While at the same time, you can also just have a return code on your method as well. So if the user just doesn't care why it failed, if they just care if it succeeded or passed, they can actually choose to just totally ignore the error if they want to and just look at the return code for a yes or no, it succeeded or it didn't, right? So anyway, let's take a look at how we do this. The key to using NSError, actually, you know what? I'm going to jump over to the main file so that we can look at it from the calling point of view first. Then we'll look at how we actually use it in the method itself. Okay. Because really kind of the calling part is kind of the little bit of a weird and complicated thing. What we're really going to do here is, first of all, we need to create a variable in our caller that will hold the error state in case an error occurs. Now, this needs to be an NSError, okay? Typically, when you create an object and you don't actually initialize it to anything, often you'll set that variable to nil, again, just for the sake of making sure that there's no problems if you accidentally send a message to it. But the truth is, setting NSError variables to nil is totally not necessary. And some people would dispute that you should do it at all. Some people would say just don't do it, because there's no way that you should be checking NS error unless an error occurs. You shouldn't be sending any messages to NS error unless an error occurs. But I like to send it to nil anyway, because I like to be in the habit of setting objects to nil. So here I go ahead and I create this NS error object, and I'm setting it to nil.
Oh, we're just declaring it. We're not creating it. Oh.
I'm sorry, we're declaring it. We're not actually creating it.
Because
You're
that's
absolutely
important.
right. That is important.
Yeah.
Because what's actually going to happen here is we're actually going to pass this reference to our variable that we created in our stack through to the method that we're calling. And then if an error occurs, then the method that we called will actually create the NS error object and put it into our variable, which we'll then get back. So that's exactly what we're doing here. We've got our client, and we're calling connect to server again, but this time we've added an extra parameter onto the end of it here, and we're actually passing the address of our error pointer. Okay, so what this is actually going to give us is, get ready for this, a pointer to a pointer. So it's actually going to be, we have our pointer, our NS error pointer here, and what we're actually going to pass is a pointer to that pointer.
Right, let me make sure I understand this first of all then. Okay, so just quick flashback. A pointer is a variable that points to some data in memory.
Right.
Okay, so our data in memory is the object, whatever it might be, and our pointer contains the address of the data.
Yes.
So a pointer to a pointer, I'm making the assumption, is another pointer that points to the address of this pointer.
Yes.
Which is pointing to that. So it's not pointing up to the object, it's pointing to our pointer.
Right. It's a lot of pointing to pointing.
Yeah, okay. I'm sure you're going to tell us why we need that in a minute.
Yes. So, so we pass in the address of our error pointer, okay? And then we also have a return code that comes from this method too. So what we're going to wind up doing is we're going to say, if this succeeds, then we don't have to do anything with it. We're all good. We can do stuff with the server here. If, on the other hand, it fails, then down here we can actually say, okay, it failed. Now I can actually say error, what happened? What is the localized description of that error and so forth? I can actually, because what ultimately happens is the method that's called is going to create an NS error for us. And because we have this pointer to this pointer that actually points back to our variable here in our current stack, it's able to essentially write that new object into our error pointer.
Right, so let me make sure I got this. I might get this wrong. Okay, we're going to go. No, so we've got no memory at the moment because we've not created anything, but we've got our pointer ready to point to that memory, and we pass it effectively another pointer to that pointer.
Yes.
So this is what goes in. If there is an error, somewhere in here, it creates an error object up here, which will then have a pointer.
Yes.
And it puts that pointer into our pointer.
Correct.
Which is why we had to have a pointer to a pointer.
Yes.
What it needs to give us back is the pointer, not the error.
Precisely. It sounds more complicated than it really is. The important things are, you're going to create this, you're going to declare this error variable. You're not going to initialize it. You're not going to set any, you're not going to actually create the error. And then when you pass it, you're going to pass the address of that pointer to the method call. And then kind of the magic happens on the other side. So let's go take a look at the other side and see how that works. So here's our method again, where we are connecting to the server and something's gone wrong. And here's our method signature for this connect to server method. Now, first of all, of course, we're returning a bool to indicate success or failure. That's very important. When you're dealing with errors in this way, you need to be returning some kind of indication of success or failure. It could be that maybe you return a successfully created object if it succeeds, like, so in other words, you'd be returning an object here, or maybe you return nil if it doesn't succeed. That would work too. Just something that you can easily say, if whatever call is there, if that, then you do the success part, else you do the failure part, right? So in this case, we're just returning a bool. And then if you look here, we've added on this with error part of the method signature. And this is where that pointer to pointer syntax comes in. If you look, rather than just having an NS error star that we're passing in here, we actually have an NS error star star. That's the NS error pointer to pointer.
Okay, yep.
Okay. Now it gets a little bit sticky too as we move along here, so stay with me. So again, we check to see if we create our socket. Okay, we failed. Now the server's not reachable, so let's create an error to tell the caller what actually happened. And so what you do is, first of all, you want to create an error information dictionary. Now this error information dictionary contains essentially information about the error, and it has it's a standardized dictionary. It's got some standardized keys that you use to fill in particular values. In this particular case, I'm just using one particular key, which is NS localized description key.
Right, so we're creating an NS dictionary, which is actually just a standard dictionary object. It's not special for NS error.
Right.
Okay, and we're going to cover that. And we're going to cover that in the foundation section. But NS error will expect there to be certain keys created inside this standard dictionary.
Correct.
Okay.
And the one that we're using here is NS localized description key. And so we're basically saying the localized description for this error is server is down. Then we're actually taking the error. So after we've created this error info guy, now here's where we're actually going to go create this error, this NS error object, and we're actually going to poke our way back through that pointer to a pointer, back to our caller, back to his NS error object sitting out there, and we're going to fill in that NS error object for him. And the way that we do that is by dereferencing the error that came in, which actually needs to be called out error because that's what we've called it here. So we've got this out error object coming in, and we're actually going to dereference it using the asterisk syntax. Right?
So when you dereference a pointer, it gives you what it was pointing to.
Right.
Now, because we had a pointer to a pointer, when we dereference our pointer, it gives us
that
our
original
pointer, which in this case is our error variable back up in the caller.
Exactly. So we go ahead and we dereference that out error pointer to a pointer, and we initialize it with a new NS error, just like if we had that actual variable right here in our code. And so that's what this, I like to use extra parentheses in here because, like I said, I like lots of parentheses. Maybe I should have been a Lisp programmer, but the extra parentheses are not actually necessary there. You could just do star out error, but I like to have that, that I just like it looks nicer with the extra parentheses. So you just say star out error equals NS error, error with domain, and then there's a few parameters here that you pass to the NS error constructor. The first one is a domain name. Typically, you're going to set this to whatever descriptive name describes the object that generated this error. In this particular case, I'm calling it network client. But this might be used. You might use, like, for example, reverse DNS notation to indicate your application name or something like that. Using com dot whatever your company name is dot some application name, something along those lines. So this is more or less sort of a descriptor of who made this error. Then there's an error code, which is an integer value. In this case, I'm just using 404, but I mean, it could be anything, right? It goes back to those error codes. If you wanted to have an error code that was looked up in some kind of a table, that's where you would put that error code. And then finally, you give it that user info dictionary that we created, the error info dictionary, and then basically you've constructed the NS error object. So now at the end of this whole method at the end of this if block here, you then return no. And what's happened is back on our main, right, we got false out of this, we got no out of this, and so we are actually able to then access the NS error object and get that description out of it that we stored in the error info dictionary using the localized description method.
We've spoken lots about pointers to pointers and whatever else, but the reality is if you just follow that syntax, it will work.
Yes, absolutely.
It's going to be that every time.
It's a lot simpler than it looks. And it's funny because it causes a lot of confusion. People don't really understand what the heck is it that I'm supposed to be doing with this, right? But it's basically, it's NS error. You're going to create the pointer here. You're going to create the variable to store it right here. Then you're going to pass the address of that guy into the method that you're calling. And then in the method, when you actually need to assign to that, you just got to make sure that you dereference that pointer to get back to that original pointer. Same thing goes with, the rest of this is just more of the same. I mean, you guys have seen this already when we're dealing with exceptions and things. It's just the same exact thing, just filling in different error messages, essentially. Now, I did want to show one more quick little thought about the NS error info dictionary. I kind of breezed over the NS localized description key. I just wanted to give a quick overview of some of the most commonly used keys in the NS error dictionary. So first of all, there's that NS localized description key that's there for a localized description of the error. So in other words, that'd be a good place to put some kind of a string like, could not connect. So I could not connect to the server. Another one is the NS localized failure reason key. This key is supposed to be used to give to give the reason that you think the failure occurred. So in this particular case, maybe it would be, something like server is down, right? Maybe it would be network is down if it was because the network was down, right? Next, there's the NS localized recovery suggestion error key, which is used to provide a suggestion of what the user could do to resolve the error. For example, you might say, check your network connectivity, right? Mm-hmm. Same thing with the NS localized recovery options error key. This is actually intended to be used for a dialog box for the user. You can provide an array of strings to be used for the buttons for that user. Now it should be noted that not all of these keys will always be there. Like, for example, a really uncommon one would be this NS underlying error key. If you had an error that was caused by another error, you might include that underlying error in your error. So again, they won't always be there. Probably the most important one is going to be the NS localized description key, because that's going to be what the user is probably going to see.
So I guess people's individual preference to how they handle errors, whether it's return codes, if they really want to use exceptions because that's what they're used to, I guess they can. Or using NS error, it's all just a choice. Mm-hmm. I mean, you could even create an NS error, then put in an exception, I guess, and throw it around. But I guess if you're going to be integrating with the Apple technologies, such as Core Data and like that, that is going to be using the NS error approach because that's Apple's preferred method.
It is now. I don't know. I mean, that's really sort of more in the more modern APIs. Is that NS error has been working its way through things, although it's been there for a while. But I think it's getting more use more recently. So I would say definitely, NS error is probably the way that you're going to see a lot of the Apple APIs are going to be going.
That was cool stuff.
Very cool.
What's next?
Next, we actually start to work with the Foundation framework.
No, that's really interesting. We've actually been working with the Foundation framework since the beginning, but sort of glossing over it quite a lot.
Yeah.
Well, time to ungloss, as they say.
Indeed.
When we come back.
you.